Hello students, let's continue with polynomials exercise 2.4, the last section where you need to factorize. Now if you notice these terms, they are all cubic polynomials, therefore we will have 3 terms as the factors, which is 3 factors, right? So let's take the first one. I have x cube minus 2x square minus x plus 2, right? So this can be written as x minus a, x minus b and x minus c, where a, b and c are any real numbers, right? So this is to show that since it's a cubic polynomial, it will have 3 roots. Now we can either solve it by hit and trial method, where we can take 2 as a product of a, b and c, or we can look for common terms. Fortunately here we can find common terms. So let me rewrite this polynomial for you again. X cube minus 2x square minus x plus 2. If you group the first and the second 2 terms, you will see that there is x square common here and you're left with x minus 2, right? And again you have minus 1 common here and you're left with x minus 2. Why minus 2? Because you have minus outside, therefore the sign inside the bracket changes. So I'm taking x minus 2 common, and what am I left with? X square minus 1. Now x square minus 1 can also be written as x square minus 1 square. We also know that a square minus b square is equal to a plus b into a minus b, right? So can we write x square plus 1 minus 1 square as x plus 1 and x minus 1? Yes, we can. So we are left with x minus 2 into x minus 1 into x plus 1. So by simply taking out common terms, we were able to factorize this. So x cube minus 2x square minus x plus 2 has been written into the product of its factors in this form: x minus a, x minus b, x minus c. Please take a look. So the second question, x cube minus 3x square minus 9x minus 5. Again, this is a cubic polynomial, therefore it can be it will have 3 roots and it can be written as x minus a into x minus b into x minus c, where these 3 terms are the product or the other factors of this polynomial. We can solve this either by hit and trial or by taking out common terms like we did in question number 1 of this section. But if you remove, say, x square common from the first term, you will be left with x minus 3. How about the second term? You can remove only 1 common, minus 1 common, and you will be left with 9x plus 5. So here you get x minus 3 common, as one bracket, and the other one 9x plus 5, right? I'll just write it more in a more better manner and make you understand why you can't solve this by removing common terms. Let's say I remove x square common here, so I'm left with x minus 3 and minus 1 left with x plus 5. So these 2 terms are different, therefore we cannot take anything common and we are left with nowhere, which is why we will now have to refer to the factor theorem and use the hit and trial method. So further revising hit and trial method, 5 is nothing but a into b into c, right? So we will have to consider the possible factors of 5. The possible factors of 5 are plus or minus 1 and plus or minus 5, right? So we are going to substitute plus or minus 1 as x, in place of x and find if we are getting 0. If you get 0, then we'll substitute it here and that will be the factor, right? So let me just rename the polynomial first. Px is equal to x cube minus 3x square minus 9x minus 5, right? Now let's find by trial method P of 1. P of 1 will be equal to 1 cube minus 3 into 1 square minus 9 into 1 minus 5, right? I'll solve this further. So I get 1 minus 3 into 1 minus 9 into plus 1 gives me 9 minus 5, right? This is equal to 1 minus 3 minus 9 minus 5. Okay. So I get 1 minus 3 minus 9 minus 5 is going to give me 9 plus 3 is 12, 12 plus 5 is 17. So 1 minus 17, which is equal to minus 16. Now this is not equal to 0, right? So x minus 1 is not a factor of this polynomial. Let's take into consideration p of minus 1. Substituting x is equal to minus 1 in this polynomial, what do we get? Minus 1 the whole cube minus 3 into minus 1 the whole square minus 9 into minus 1 minus 5. So I get minus 1, minus 1 cube is minus 1, minus 3 stays as it is, minus 1 square is 1, minus into minus gives me plus 9 minus 5. So I'm going to take the like terms and add them together. First of all, I need to solve this bracket. So minus 1, minus 3 into 1 gives me minus 3 plus 9 minus 5. Now we have similar terms, the negative terms, we are going to underline and add them first. So minus 1, minus 3, minus 5 gives me minus 9 and plus 9, right? This is equal to 0. P of minus 1 is equal to 0. Therefore, by factor theorem, we can say that x minus a is a factor of x minus 3x square minus x minus 9x minus 5. So, what is your a? X minus of minus 1, right? So, x plus 1 is a factor of this polynomial. So, I am just writing the value of this term, x minus 1. Now, what we need to find out is x minus b and x minus c. I'm sorry, this is plus 1, right? Now, we need to find out x minus b and x minus c. To find it out, we need to first rewrite this. So, please take a look at this section because I am going to erase the board. So what I need to do is first divide this polynomial by x plus 1 using the long division method, and we will get the other terms. We will get the quotient which can be further split. So let us solve this. I have x cube minus 3x square minus 9x minus 5, and I need to divide it by x plus 1. So x into what will give me x cube as my first term? X square, right? So x square into x gives me x cube, and x square into 1 gives me x square, right? I'll subtract, these two terms cancel. Minus 3x square minus x square gives me minus 4x square, and I bring down minus 9x. Now x into what will give me minus 4x square? First of all, let's take a look at the variable. X will give me x square and minus 4 will give me 4x square, right? So minus 4x into x gives me minus 4x square. Minus 4x into 1 gives me minus 4x. Now since there are negative signs, they will become positive here. Minus 4x square and plus 4x square cancel out. Now minus 9x plus 4x gives me minus 5x, and I bring down minus 5. Right? So x into what will give me minus 5x? Clearly it is minus 5. So this gives me minus 5x, and minus 5 into 1 gives me minus 5. This becomes plus and plus. Thus the remainder is 0. Therefore px can be further rewritten as the first term or the first factor, which is x plus 1 into x square minus 4x minus 5. Right? Now we can simply solve this by splitting the middle term. So x plus 1, and I'm putting a big box bracket here. So how am I going to split my middle term? 4x, x square minus 4x minus x minus 1x minus 5. So 4 minus 4, no, let me redo it. I need my product, I need to split 4 such that the product is 5. So x square minus 4 can be written as minus 5x plus 1x, right, minus 5. Let's check. Minus 5x plus x gives me 4x, and minus 5 into plus 1, minus 5 into plus 1 gives me minus 5. So here I have minus 5. I'm going to box it up. So x plus 1 into, what is common here, x into x minus 5 plus 1 into x minus 5. Right? Now I have x minus 5 common here in both these terms, so I'll take that common. So I'm finally left with x plus 1 into x minus 5, let me write this bracket clearly, into x plus 1. Hence we have written the polynomial into the product of its factors, x plus 1, x minus 5 and x plus 1. Therefore we have x minus 5 and x plus 1. Right? Now there are two x plus 1, so we can even write this as x plus 1 the whole square into x minus 5. So x cube minus 3x square minus 9x minus 5 has been split into the product of its factors. So we have factorized it. Please take a look. Now let us go ahead and solve the second question. The third question. So my third question is, I'm just naming the polynomial from the start. Px is equal to x cube plus 13x square plus 32x plus 20. Right? Now this is a cubic polynomial, therefore it will have 3 roots. Let's say x minus a into x minus b into x minus c, where a, b, c are real numbers. Therefore by splitting, now 20 is the constant, which is nothing but equal to a into b into c. Right? So we need to find the possible factors of 20, which are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5. How about 6, 7, 8, 9, 10? That's it. So we are going to use the hit and trial method to find the factors. Okay, let's say I take p of minus 1, right? So P of minus 1 is going to be minus 1 cube plus 13 into minus 1 square plus 32 into minus 1 plus 20. Just separating this section. Right? Now I'm going to open up the brackets, which is equal to minus 1. Minus 1 cube is minus 1 plus 13. Minus 1 square is 1. So 13 into 1 plus 32 into minus 1 gives me minus 32, and plus 20 comes down as it is. Let's solve this further. This is equal to minus 1 plus 3. I'm sorry, this was 13. So 13 minus 32 plus 20. Right? I'm going to take the like terms together and add them up. So minus 1 minus 32 gives me minus 33. Right? And these are positive numbers. So plus 13 plus 20 gives me plus 33. This is equal to 0. So fortunately, by using the hit and trial method in the first instance itself, we've got the first factor. Why? Because P of minus 1 is giving me 0. So x minus a is x minus of minus 1. So x plus 1. Therefore, x plus 1 is a factor of this polynomial. Right? Just take a look at this because I will have to erase the board. So I have my first factor, which is x plus 1. Now how are we going to find the other two factors? By the long division method first. So let's get ready to solve using the long division method. I take my polynomial x cube plus 13x square plus 32x plus 20 and x plus 1. See, now x plus 1 is a factor of this polynomial, right? Therefore, it is going to divide this polynomial to give the remainder as 0, right? That is why it is the factor in the first place. But we need to find the quotient so that we can find these two factors, right? So x plus 1 into what is going to give me x cube x square, right? So this becomes x cube plus x square into 1 gives me x square. So minus and minus, x cube and minus x cube cancel out. 13x square minus x square gives me 12x square plus 32x comes down. Now x plus 1 into what will give me 12x square as the first term. For the variable it is x and for the coefficient it is 12, right? So this is going to give me 12x square and 12x into 1 gives me 12x, right? Negative, negative cancels out, plus 32 minus 12 gives me 20x. And why 20? Because the sign of the greater number, right? Now I bring down my 20, right? X plus 1 into what will give me 20x is my first term. Clearly it is 20. So 20x, 20 into 1 gives me 20. See, x plus 1 we know that it is a factor of this term, that is why we are getting the remainder as 0. So px can be written as x plus 1 into x square plus 12x plus 20 plus 0 actually, because dividend is equal to divisor into quotient plus remainder. The remainder is 0, which is why we haven't written it. Now we can simply split this. We can find the factors using by splitting the middle term, right? So x plus 1 into, how about 20? We can split 12 into 10x plus 2x, right? Because 10x plus 2x is going to give me 12x, 10x plus 2x gives me 12 and 10x into 2x gives me 20. I'm sorry, 10 into 2 gives me 20, right? So x plus 1 I take x common from the first term, I am left with x plus 10 plus 2 into x plus 10, right? So now here we have x plus 10 common between these two terms. So I am going to take it further common outside. So I am left with x plus 1 into x plus 10 into x plus 2. This is px. So we have factorized px, that is x cube plus 13x square plus 32x plus 20 into the product of its factors, which is x plus 1, x plus 10 and x plus 2. Please take a look. So this is nothing but your answer. Moving on, let's go to the last sum. Oh, this was the third sum, by the way. Let's go to the last sum, which is the fourth sum. So I'm naming my polynomial first. Now this is a polynomial in variable y. So I'm going to write it as py is equal to and not px is equal to, okay? Like we did in the other sums. So this is my fourth sum. Py is equal to 2y cube plus y square minus 2y minus 1, right? This is a cubic polynomial, therefore again it will have three roots which can be written as y minus a into y minus b into y minus c, right, where a, b, c are real numbers. Now you see that you have a coefficient here, so you will have to rewrite py, or you can just take minus 1 as the constant. Let's see the possible factors. The possible factors are plus and minus 1. So let's find p of 1. 2 into 1 the whole cube plus 1 square minus 2 into 1 minus 1, right? This gives me 2 into 1 plus 1 minus 2 minus 1, which is equal to 2 plus 1 minus 2 minus 1. So everything cancels out. So using the trial method, we found the first factor, y minus a. So y minus a is going to be y minus 1, right? Because p of 1 is equal to 0 by the factor theorem. Now we need to find the other two factors, which we will get by using the long division method. So using the long division method, now y minus 1 is a factor of this polynomial, therefore the remainder is going to be 0. We need the quotient so that we can find these two other factors, right? So my dividend 2y cube plus y square minus 2y minus 1 divided by y minus 1. Now y minus 1 into what will give me 2y cube? Let's see the variable part. First for y cube we need y square and 2. So 2y square into y will give me 2y cube, right? And 2y square into minus 1 will give me minus 2y square. This becomes negative and this becomes positive, right? So y square plus 2y square gives me 3y square. I bring down my minus 2y. Now y minus 1 into what will give me 3y square as my first term. So clearly for the variable I have y and 3. So 3y. Y minus 1 into 3y will give me 3y square as my first term. So I get 3y square plus 3y into minus 1 gives me minus 3y. Right? So minus and plus. Minus 2y plus 3y gives me 1y, which is nothing but y, and minus 1. Y minus 1 into what will give me y minus 1? It is 1. So plus 1. Minus and plus 0. Thus we got 0 as the remainder, because obviously y minus 1 was a factor of this. So now py can be further rewritten as y minus 1, so dividend is equal to divisor into quotient 2y square plus 3y plus 1. Dividend is equal to divisor into quotient plus remainder. Remainder is 0, so we are not writing it. Right? Now y minus 1. Now we need to split 3y such that we get the product as split it into two terms, say y1 and y2, such that the product of y1 and y2 gives me 2, and adding it would give me 3. Clearly it is very simple. We have 2y square plus 2y plus 1y plus 1, right? I have y minus 1. I take 2y common outside. Let's make this a box bracket. So what am I left with here? Y plus 1. Since 2y is already out, I am left with 1 for the second term. There is nothing common except 1 in the second term, so I get 1 into y plus 1, close my box bracket. Now again y plus 1 is common in both these terms, therefore I have y minus 1, y plus 1 into 2y plus 1. This is p of y. So we have factorized a polynomial py into the product of its factors, which is y minus 1, y plus 1 and 2y plus 1. So the factorization is complete. Please take a look. So we are done with the fourth exercise, that is 2.4 of chapter polynomials, and we will continue with the remaining section in the forthcoming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.